Okay, so we're 2 minutes past the start, so let's get cracking. So welcome everyone to today's demo. So today we're actually doing a release demo for the new 1.5.0 release. So that was released late on Monday, but this is the first official kind of communication. So if you subscribe to our GitHub repository, you probably already saw this, but we wanted to give a brief overview because it's actually a fairly big release. Which includes a lot of new features, which we've also, a few bigger features that we even started like last year that didn't make it into the 1.4 release, but we finally made it into the 1.5. So like all the releases, if you want to check out the release notes, you can check that out from our GitHub page and link it from the thinedge.io webpage. And you can kind of have a look. So we try to highlight the what is kind of the most interesting bits or the bigger features. But I would always recommend reading the whole thing. It's a little bit long, but it's usually a good sign that the project is very, very healthy and active. So for the demo today, we're going to be going over basically like the feature highlights for this release. And then I'll give a quick summary of some of the additional kind of, noteworthy mentions. So we'll cover like the certificate authority feature from Cumulocity, which is an upcoming public preview feature, HSM support, so hardware security module support, the entity store HTTP API, and also now that we support connecting ThinEdge behind a HTTP proxy to make it basically more usable for a lot of more like factory settings where you don't have direct connection to the internet and have to connect via a HTTP proxy. So as mentioned, the changelog is available, but maybe if you don't know, so we also detail on the website that all of like the Linux artifacts are also publicly hosted, and I'm getting a forbidden sign. I'll update that link. So it's on Cloudsmith. Everything is publicly available there. And also the images, so like the container images. So if you want to build your own kind of IoT solution on top, you can pull it from our GitHub container registry. So all of these are freely available and can be consumed and built into your IoT projects. So, sorry, let's go back. So moving on to the first highlight feature, I'll hand over to Didier and Rena, where they're going to give another overview of the Cumulocity certificate authority support in ThinEdge. So over to you, Didier.
Yeah. So what I would like to show you is how to use a new feature of Cumulocity, a feature that will be soon in preview. And this is how to distribute a certificate to devices. So here I have a device that is not connected to Cumulocity, and for a very good reason that this device don't have a certificate. So there is no certificate on this device, and I would like to have one. And so for that, I will use this new feature of Cumulocity. So I can register a device as usual. And the new part is that I can doing so using certificates. So I would like to provide two things: a name to my device, say demo 1.5, and I would like to provide a one-time password. I will come up with something that is random. And now I have this device ready to be registered, meaning that this device can retrieve a certificate. For now, this device is not here. If I go there is no such certificate device. But from the certificate, using Synedge, I can so there is a set download command, and we'll be able to request a certificate for this device. So it was the name. Sorry. Try. And this one-time password is requested. So I have to provide this one-time password again. And provided I know this one-time password, I will retrieve the certificate from Cumulocity. So just during this command, the certificate has been generated by Cumulocity. I can check that here. So the certificate issuer is Cumulocity, and more precisely, the tenant. And I can see in the oh, by the way, this activation is gone. This has been this is just something that can do once. And the certificate is coming from Cumulocity. So now in your tenant, you have a certificate that will be used by all the device using this feature. So my certificate has been signed by my tenant. And now that I have a certificate, I can connect to Cumulocity using this certificate. So everything is fine. I can check now that I'm properly connected, but see some same command as before. And just touch connect test. I'm properly connected to Cumulocity using this certificate. So that one that has been provided by Cumulocity. And I can check here that I have this new certificate device. Yes, the new device is here connected to Cumulocity since today. So now I have a first certificate, and if I can, so just go up. Now I have certificate, but this certificate will be valid just for a given time. In that case, 1 year. And so I will have to renew the certificate from time to time, and obviously before having this before the expiration date. And for that, there is a new command that is cert renew. And this command will use exactly the same path to Cumulocity to renew the certificate. So we'll go again. So I will do this in I can do this explicitly telling, oh, I would like to renew the certificate from the CA that is Cumulocity, or this is implied, in fact, in this case. And my certificate has been renewed right now from Cumulocity. You can notice that it's, I get 2 minutes more, 2 minutes more from my certificate validity. And this has been done using exactly the same service. So behind the scene, I'm using the CA service of my tenant, and this device certificate is signed by again by the certificate. And in that case, you need something that is different. And to have a new certificate, I have to provide a one-time password. Here, I don't. Why? So the one-time password is used for the very first certificate because Cumulocity need to trust the device. It will not give a certificate to any device requesting one. And so the proof is that this certificate is trusted, is that some guy, an operator, in that case me, copy pass the one-time password from the Cumulocity to the device. And this is very flexible. I will show you, yeah, maybe not today, but we can also do the reverse. That's a certificate, the device generates a one-time password, and an operator will give this one-time password to the tenant. The key point is that for the very first certificate, we need to the device need to trust the tenant, and the tenant need to trust the device. And in between, we have the operator that is giving this one-time password to both. To renew a certificate, we don't need that. We are just using the fact that the device is already connected to the cloud, already authenticated. So the trust is just going through the normal path. So using the MQTT, where we're using this certificate. So the current certificate we use to authenticate the device. And provided this authentication, Cumulocity can give the certificate. But now, I'm in some intermediate position. Maybe you can notice that here I have a certificate that is testcertificate.pem, but what has been provided is a new certificate that is placed elsewhere, and this is done on purpose. We don't want to take the risk to break the connection when we have a new certificate. So this new certificate is just put aside, and I will have to reconnect. So I will do this right now. Let's reconnect Cumulocity. And during this reconnection, there is a key step, the validation of the new certificate. So in that case, this new certificate is used by the Tech to connect directly the cloud without any bridge, direct connection to the cloud. And if the connection is valid, the Tech reconnect command just swap the two certificates. So the new certificate of the device is now this one. And we have something that is safe. We can have something where I renew certificate, and when I'm ready to reconnect, I can reconnect. And if for some reason I cannot reconnect, say the download failed, or only some bytes has been given, or I'm unlucky, the network is down, the new certificate will just be kept aside and will be reused in a second attempt, then a third, and at the very end, if this certificate cannot be used, Synergy will takes a safe side and keep the previous certificate, change nothing. So this is the first part, renewing, having a new certificate for a fresh new device, renewing certificate. And we have also a case that is very, very, most of you will have this use case. You have a Synergy device and running with previous setup. So using a self-signed certificate. So I have one of these certificate device there. So this is a demo container. And if I show my certificate, I have a certificate, and this device is connected to Cumulocity. But this is done using a self-signed certificate. And I can see this is self-signed certificate because the signer, the issuer, is the same. This is the device itself. The device signs its own certificate. And so I would like to switch from this self-signed certificate to something that is provided by the tenant. In that case, I just have to leverage the fact that I'm connected to Cumulocity. The test is positive. I'm connected to Cumulocity. So Cumulocity is aware that I'm a trusted device, and I can simply request renew of this certificate. And I have now a new certificate, and you can check that now this new certificate has been given by Cumulocity, and more specifically by my tenant. And as before, I have to reconnect to Cumulocity to make this new certificate actually used. And so yes, it's nice. So again, there is a check. The check has been positive, so I can use a new certificate. And now my device is ready using the new to work with a self-signed certificate. So, with a certificate properly signed by Cumulocity. And so this is some more very easy. You just have to issue this touch renew to have a new certificate given by Cumulocity, provided you are already connected to Cumulocity.
So there's a key point there, because a lot of existing customers who are maybe longer time Finet users may have already gone into production with self-signed certificates, or like late QA kind of phase. So this means like the certificate renewal process, because there's also a systemd service that will do this automatically, will actually auto transition to the CA, the Cumulocity CA. So provided that the feature is enabled in the tenant, then it will just automatically transition. So you wouldn't even need to have to be proactive about it if you're happy to kind of still live with the self-signed certificate until it kind of gets near the expiration date. Or you can kind of proactively trigger it using the manual commands as well. So it's a nice seamless upgrade path for existing users as well.
Yeah, because we have a service that is a service to renew automatically the certificate. And yeah, roughly the idea of this service that will run every hours is simply to check is the certificate but still valid or not. For instance, there is, I can run this command manually. And yes, my certificate is valid. And this command return a valid result. So in that case, this command return an error because the certificate is still valid. So why this has been reversed? It's simply to be able to write this kind of check. So this one is using systemd, but you can have your own script, cron job that will do the check. So this will proceed only if this is successful, so only if the certificate needs to be renewed. In that case, we will proceed to the second step to renew the certificate and then to reconnect. And a key point related to that is that when you have a certificate, let's show. So we have this validity date, validity period, and this is something that you can configure. So you can, if you touch config, yeah, there is this one list certificates. There is a number of things you can configure with this around certificate. And this is how long you want to have your certificate valid. On that point, this will be tuned by Cumulocity. If you are requesting 6 years, Cumulocity will say no, 1 year is enough. On our side, on the senior side, you can say, oh, I would like to renew my certificate even if I still have 30 days left. I want to be cautious and to renew my certificate sooner. But I can change this number and to say, oh, I would like to renew just 5 days before, or vice on the contrary, 2 months before. And by the way, you can also configure the organization unit of your device. This is what you have here. You can provide your company name and business unit name, whatever, along your certificate. So this is the subject, so the device name and the organization information. So this can be configured for your device. So that is for me.
Yeah, so yeah, we'll hand over to Rena, who will just give a quick overview of, so once we have this feature, we also want to, how does it integrate into other tooling? So for example, if you have like your images, if you're using like RugPy, which is now called RugX, or Yocto, like how do you kind of like bootstrap those devices? So we already had a extension to support this. So we want to just kind of demo how it could kind of look like in a more production-like setting. So over to you, Rena.
Yeah, thanks, Ruben. So I'm going to share my screen now. Okay. So as Ruben mentioned, so we have support to make your custom Linux image by using RugX and Yocto. So they are documented. So if you are interested, please refer the document. And also we have a GitHub repository accordingly. So yesterday what I did is I used exactly this RugX image repository, and I baked my own Linux image for Raspberry Pi 4, and then flash my SD card, and I just inserted the SD card. So the thing is now my Raspberry Pi 4, which is in the local network connected and powered, and that already has a thin edge inside, but not yet connected. And now with this 1.5 release, since we have support for CA, Cumulocity CA, and when you onboard your custom Linux image device, and that consumes the CA certificate from Cumulocity from the beginning. So then now I'm going to show you. So I'm going to use go CA command, and with the touch extension, CA scan, which is very helpful because you don't have to know about the IP address of your Raspberry Pi. Actually, I don't know my Raspberry Pi address at all, but I can just take this one. And then next step is see advantage. Like you connect with SSH, actually exactly connecting with SSH. Bootstrap. Sorry, I forgot. Bootstrap. Yeah. Then it's like a magic.
So maybe just to explain a little bit that magic. So because we figured, I think everyone that we've spoken to wants to use a certificate authority feature when it's available. So by default, the Bootstrap command will check in your tenant, is that feature available, and will use it if it is. If it isn't available, like if you haven't enabled it, it will then go to the default, which is using a local CA. But we figured that because everyone wanted to use sensible defaults, which is using it where possible, that's why we opted for this. You can control that if you're not happy with that. You can force it to use a specific CA, but I believe everyone will be quite happy with that kind of change. It's a seamless kind of integration then.
Yeah, so then after this bootstrap command, so this Raspberry Pi is already connected to Cumulocity, and the device management page is popped up automatically. And the point is, yeah, the certificate. Here you see issuer is Cumulocity, so it's not self-signed certificate. Yeah, and that's it from me.
Yeah, perfect. Thanks, Rena. Yeah, so like before, that also works for the Yocto images if you're using the thin edge Yocto layer. So it's a common pattern that we have for the images that we support building. Okay, so now we wanted to give a quick overview of the entity store API that we put in. So for that, I'll hand over to Alvin.
Yeah, thank you, Ruben. So let me share my screen quickly. Hope you can see the browser.
Yes, we can.
All right. Okay. Okay. So with this 1.5 release, we are introducing HTTP REST APIs for entity management. So from the very first release, we've had the MQTT APIs that lets you create entities, manage them, etc., etc. But we have added support for the doing the same with over HTTP as well. So the primary use case for providing the HTTP API was that one limitation with the MQTT ones. So for example, when you try to create an entity, just for those not familiar with the terminology, entities are devices and services in the thin edge world. Okay, so all the child devices that are connected to thin edge, or all the services that are running on individual devices. So this is what we refer to as entities. Okay, so with the MQTT APIs, when you try to create a device, so it's a MQTT publish. So you publish to a topic with a payload, but you don't get any feedback whether that entity was successfully created, whether the payload was malformed, whether there's any other issues. For example, you try to create a child entity to a non-existent parent. So then ideally you would have liked the feedback that, okay, this parent does not exist yet, so you need to fix that. But such a feedback was not available with the MQTT API, and this is one of the primary things that the HTTP API fixes. So when you make a request, you immediately get the feedback. Okay. And the second use case is obviously, so for if there are some child devices that are already HTTP ready, then they are not forced to switch to another protocol, MQTT, to do all the entity management, so they can continue using the same protocol that they are familiar with. Okay. So yeah, just a quick overview. So we've, as I said, so we've got APIs to create entities, fetch individual entity definitions, query all the entities that are there registered with thin edge, update the entity, delete the entity, and then for the entity twin data management as well. So twin data is additional metadata that you attach to the entities, for example, the name, type, or any other custom fragments from the Cumulocity world. So yeah, we've got a pretty complete coverage in terms of the HTTP APIs. Okay, so let's quickly jump to the demo. So I'll just show you some of the most commonly used APIs. So first, let's create an entity. Okay, so entity you create with this. I'm using the curl command, I'm posting. And this is the API endpoint. So we already have the HTTP server running on port 8000. So this has always been there. So we had something like a file transfer service that was there that supports the configuration management, log management, and such features. So to that same HTTP server, we have added the service, the entity store service as well. And this is the endpoint, TEV1 entities. And you need to provide the payload. So the payload, in the payload, you specify the topic ID. So I'm going to create the child0 device, which is of type child device. So let's create that, and in the response, you will get the topic ID of the entity that was just created. Okay. Now, as you can see, with curl, the payload is already a bit verbose. The command is a bit verbose, and if this server was secured, SSL secured, then you would have to provide additional parameters to the third path, the key path, the CA third paths, etc., etc. Okay. So to make the life easier for the user, so we have introduced another utility, a touch HTTP utility, which is very similar to the touch MQTT utility that has existed, if you're familiar with it. That lets you interact with this entity store service. Okay. So you can do a creation using this API in a similar manner. So touch HTTP post you do, and then instead of providing the host port and all that, you just provide the path. For example, even entities, and you provide the payload. And that's it. So the port and say any other secure configuration settings and everything will be read from the TNET's configuration file by this touch utility. So that's why you don't have to explicitly specify anything. And since 0 exists already, let's create 1. Okay. And so I've created one more entity. And in the interest of time, let me use my cheat sheet and create a few more entities. Okay. So now I've created a hierarchy, a nested hierarchy of entities, so 2 levels, and let's just try to view them. So the same thing you can do with touch HTTP get, and you hit the same path. And as you can see, it will show all the entities that are there. The main device, the child device. So there are 2 child devices, immediate child devices of the main device, and there are some nested child devices, child 00, child 01, child 02, which are children of child 0. Okay, now instead of for the rest of this demo, I will be using this web UI. So this is a UI application that I've created just for the sake of this demo. So this is not the official part of the official product, the next product, as evident from the quality of the UI, I guess. So this will be used to visualize the entity hierarchy and all the operations on it. Okay. And as you can see, so this is showing the main device and its children. So let's refresh that. And so yeah, as you can see, it shows the entity metadata, all the child devices, and all the child services. And now if you navigate to one of the child devices, you'll see that, okay, it has further children in it. Okay. So this is how it is. Go back to parent, child 2, and stuff like that. So this UI is using the exact same APIs that I've been showing so far. Okay. Now, there are a few APIs that makes it easier, so which are difficult. So some operations that are difficult to do with MQTT, which the HTTP APIs makes very easy, right, with a single command. So for example, assume that in this particular case, this child 02 was wrongly attached to child 0. So this was attached to the wrong parent. I would like to attach it to child 2, another parent. Okay. So for that, what you can do is, there is a new API, touch HTTP patch available, and you provide TE1 entities, and then you specify the target. So what is the entity that you want to update? So I want to update child 2 entity, and the update that I want to make is I want to change its parent, and the parent would be device child 2. Hope I have typed it correctly. So I'm going to update the parent of child 02 into child 2. It's currently child 00. And the update has happened. Now, if you navigate back, you will see that child 0 doesn't have child 2 anymore as a child, and it has been moved to child 2. And the same change actually reflects in Cumulocity as well. For example, we go here. So we've got all the child entities, and child 2 was actually a child of this one earlier, but it has been moved to child 2. So that change propagates to the Cumulocity cloud as well. So yeah, that's how it's currently now. So that's the creation, fetch, and update part. So now you can actually change the twin data of your entities as well. So there is an API for that. For example, navigate back, and all the child devices of the main device. So for example, the name of this child 1. So it is a very long name. I don't like that. I would like to change it. So what you can do is you can update it like this using the put API. So there is the put API. So you provide the target path and then twin name. So that's the name fragment is what you want to update with the updated value. You update that and refresh it here. You'll see that the update got reflected. Okay. Now, the final thing, it is about deleting entities. So for that, again, we'll go back to our private UI. So in this case, as you can see, child 0, this entity has multiple children. Now I would like to delete this child 0. So if you are to do it with the MQTT APIs directly, then you would have to delete multiple. So you'll have to clear multiple topics that corresponds to all these child UIs and extra. But with HTTP, it's just a simple delete call. And it will delete this target entity as well as all of its nested children. And that's gone. So if you navigate back to the home, so yeah, child 0 and all of its children are gone, which you can verify here directly as well. So child 1, child 2, and all the other things are gone. And child 02 is still there because it's a parent, it's a child of child 2 now. So yeah, that's pretty much everything that I wanted to show. So that's a complete set. And for those interested, so we've got the complete documentation here under the operate devices section, registration. So yeah, feel free to explore. And if you got any feedback, yeah, please share it as soon as possible. Yeah.
Thanks, Alvin, for that. And maybe just to kind of preface it, so the API is really great for UIs. So if you want some kind of local UI to maybe manage a few things on the device or get more information from the device, it's really useful. And that was just created yesterday. So it's quite easy to kind of integrate into or build your own kind of layers on top to then use the API in a really convenient manner. So it's easy to use, easy to consume. What more can you ask for? Cool. Okay, so I'm just going to then share my screen again. And just looking at the time, I'll be a little bit brief with these two. So I wanted to give a brief overview of the hardware security module support. The last public demo was basically a long information session discussing everything related to HSMs and the PKCS11 format. So I won't go over that stuff again. I just wanted to kind of reiterate that we now support it and show it live on one device. So we interface with HSMs using PKCS11 format. So you can store your private key within that module. And that basically makes it unexportable. You can't steal this anymore, and we don't actually have direct access to it. We can use it for establishing a secure connection with the cloud, but we don't actually know what the private key is. And that's the best way to protect something. Don't expose it. So that means that you can interface with a lot of HSMs. So if they have this PKCS11 interface, we support it. So some examples of that. So if you want a USB style kind of hardware, so the Nitro Key HSM or like the YubiKey 5s, we would kind of recommend the Nitro key over the UB key because I think that the Nitro key implements more of the PKCS11 interface. So you'll just have a better kind of easier to integrate with additional tooling on top. It means that we can also support TPM 2.0 modules because that also that supports this interface, and also like the ARM trust zone by the Opti, again, something that offers the interface. So all of these changes in the latest 1.5 are now in our Yocto layers and the RugX. So RugX is formally named RugPy. So all of that's included by default now. And so I'll just give a quick demo showing a RugX image that I have. So I'm on a Debian-based system. And then here you can also see, so if I just run that again, if I'm just kind of scanning, hey, what kind of modules do I have, or slots as they call it, I can see that I have a Nitro key HSM plugged in. And that has actually already been pre-configured because I've done this myself. I've initialized the private key and then used the GNU TLS CLI commands to then generate the public key. So now that I'm actually already connected. So how does that even look when you're connected? So with a lot of the other improvements, I think since 1.4.2, pretty much all of the key information that you need about your connection.
Are you sharing your terminal?
Yes. Sorry, not the terminal. Sorry, 1 second. So I didn't click on the entire screen. Okay, so let's just do a list again. List slots. So I'm on a device which is a Debian-based on the RugX, as I said before, and I have a Nitro key plugged in here. So it's already pre-configured. So that's kind of like up to you to do because it's kind of belonging to this kind of onboarding of your HSM. You need to initialize it. But there's a lot of great tools out there like the GNU TLS tools. So cert tools supports all of this, or some kind of like integration partners like Devity support initializing all of these private keys. So now that I'm already connected, but I just want to kind of show how that kind of looks when you're connected. So if I just do a connection test, I can see here by the crypto key true that I'm actually using the PKCS11 interface. And so I'm still using the file. So like the public key is still there as a file-based thing. That hasn't changed. And if I look in the device certs, previously, if you're using a file-based private key, you'd actually see another file called TEDG private key or something like that, or private certificate. So you can see that's not there anymore, and I'm still connected. So it is actually using behind the scenes an interface to the actual module. So to facilitate all of this, there's actually a new service run here called the TEDG P11 server. So that's a service which offers like a socket interface, but that's all implementation details. But ThinEdge is aware of that, and you can configure ThinEdge to then use this interface to then do all of the required signing for establishing the secure connection to the cloud. So part of the secure connection is doing basically like the TLS handshake, whereas during the handshake, you need access to the private key to kind of use it in a signing kind of operation. So you can actually see when it's kind of used. So it's only used on that establishing the connection. So you can kind of also diagnose that by looking at the TEDG P11 service, which is running on the device. If you want to inspect a few of the configuration elements, so crypto key. So I can filter, and if I want docs there as well. So the config list also supports like filtering and adding docs and all this kind of nice stuff. So I don't need to use grep anymore. And I can even get all of the configuration parameters that I can use then to configure the PKCS11 stuff. So here I'm actually using, so if I don't do that, I'm using the socket-based, so that's communicating with the TEDG P11 server. I define what PKCS11 module, because that's basically the fundamental, how do I talk to this kind of bit of hardware? You need a shared library object. And also if you have like defined your PIN for accessing that. So everything's fairly defined. We'll be adding documentation which explains all of these kind of steps. But since it's a kind of a new topic for a lot of people, I'd probably wait until the documentation before getting into all of that. But you can check out all of our system tests to have kind of a bit of an overview, because that also has, a system test for it, which also shows how to use like soft HSM if you're just kind of like experimenting with things but don't have any hardware yet, that there are kind of tooling available to kind of still, get familiar with the technology. Okay, so looking at time, I'll jump to the next one, and we can have some open questions towards the end if there's any. So the last feature that we want to show is support for the HTTP proxies. So this is basically if you're in a factory floor, and maybe your device doesn't have direct internet connectivity, because the IT rules in the factory can be quite stringent and say all communication needs to go through the proxy. Then previously we didn't support that. So basically you'd get timeouts on all of your actions. So now you can configure it to saying, where is this HTTP proxy that I need to communicate to? So the only kind of limitation is it needs to support HTTP tunneling. So that's the tunneling by the HTTP connect method. So what we've seen is most support this, because that is kind of reliant on how we're using it, because we want to keep on using MQTT over TCP, because we don't want to switch to WebSockets, because we would lose some other kind of functionality like certificate-based authentication at this point in time. So that's the only requirement. So if that is supported, then I can show you how that kind of looks. So for this, because it's hard to get a environment which is forcing HTTP communication, so we actually have a unit or like a system test for this, which I'm going to use to demo this. So I'm just going to spawn a container, which then has a HTTP proxy inside it, and also IP table rules, which basically rejects anything trying to communicate with the outside world that isn't going through the proxy. So I have spun up the test container at the moment. And so if I do like a ping on Google, we'll see that nothing works. Okay, the DNS worked, but apart from that, nothing else. I can do a curl google.com, and same thing. It just hangs because the proxy or the IP tables is blocking it because I haven't defined the proxy. So with this, so just to prove that the proxy is then even defined, and see that Google works, or like the curling Google, because curl supports reading this environment variable, and then everything works as expected. So we've added to the documentation, just quickly show that. In the install page, we now give a bit of hints. Hey, if you're using a proxy, you need to set these settings. We'll be adding a different page if you want to configure it retrospectively, but the installer is also proxy aware, because you can't install something also behind the proxy if you don't set the proxy settings. So with that, so you can export the HTTP proxy environment variable, so specifying the IP address, port, and username password if the proxy requires that. So that's what I'm going to do here. So I'm on my device, which I can't communicate with the outside world. I export the HTTPX proxy, so my local proxy doesn't actually require username password. And then I use the exact same install script as before. So the install script is now proxy aware, and we're going, okay, you've specified a proxy, so it will detect environment variables, and that's why we exported that environment variable. And it will, even if you're on a Debian-based system, set your APT configuration, because that also needs to be proxy aware. So otherwise your APT will fail. So that's automatically configured, and you'll see it just kind of works. I didn't really even know it was using a proxy, but everything just worked. So that should be really convenient. If I just kind of proceed to the next step, because I don't want to have to do everything myself, like, create a certificate, upload it, and all that kind of stuff. So if I just do the tech connect command, it works. So it's connected fine. And again, to show, the TED Connect, and when you're connecting to some kind of external cloud, you kind of need to know, what am I using to connect to the cloud? So if it doesn't work, you have a bit of like clues what's going on. So you can see here, I am using a proxy because I've configured that. So it's very in your face to saying, yes, I am using a proxy, because maybe if you have like, if it fails and you're going, oh, that's the wrong address or the wrong port number or whatever. So it's very quite easy to use, and everything should just work as it did before. So let's just go onto the EU latest, go to my newly registered device. So all of the communication works. So, you can get set configuration, everything will go through the proxy. So it should be a really seamless kind of experience. And you can also like change the configuration. So if you list and just do on a proxy all, you will see these 3 new settings. So this is actually 4. So where you set the URL, so like, whether you're using a HTTP or a HTTPS proxy, IP address and port, and then you can define the username password, as well as a no proxy, which is basically what URLs shouldn't go to the proxy as kind of like standard proxy interfaces. So hopefully we make ThinEdge even more kind of like consumable and usable in different environments. So if you notice something doesn't work or something like that, please, create a ticket on GitHub, and then we can address it quickly. So just spending the last 2 minutes on some other noteworthy things, because it was such a huge release. So we had like tab completions being added. So all of our Yocto and regex images also have tab completion out of the box, which is very nice to discover, settings and stuff like that. We have also, you can now control whether devices, so child devices, appear in the Cumulocity all devices list. So we opted for a non-breaking change for existing ThinEdge users, so that will not be enabled by default. But if you want the child devices to appear, so all this all devices list is here, you can change a TED setting to tell ThinEdge to saying, yes, I do want to create new child devices with the additional CAY is device fragment. So that just basically is a fancy way of saying it will appear in this list. At the moment, it's only the main device that appears on this. That can be good and bad, depending on your kind of use case. Then we have you can now fine tune the keep alive interval for the MQTT connection. So if you're on really bandwidth constrained devices and want to limit, the ping interval to change that up to, like 30 minutes or 20 minutes or whatever your kind of preferred value is, you can change that. We had the last remaining piece of the supporting Cumulocity Smart REST 1 kind of topics, that now you can actually control the device ID just via TED-TOML. So previously, this was always read from the certificate, because if you're using certificate-based communication, the common name in that certificate is your device ID. But for basic auth users, which is what is required when using Smart REST 1, it always had that kind of, well, how do I set my device ID if it's not coming from a certificate? So now you can just set it like any other configuration in the TED-TOML, and also via the TED config set command. Then the TED MQT sub also got some nice improvements. So you can subscribe for a specific duration. You can say, only for 2 seconds or 10 seconds or 1 minute. You can also say the count, that I want to stop subscribing after 5 messages. And also you can filter for retained messages only. So all of these kind of make it nicer to build into some scripts. If you need to do something with the local broker, you can do some really nice kind of like, it's easier to do scripting, and you don't need to resort to using Mosquito sub, because MQT, so the TED MQT sub has the advantage is because it's context aware. So it doesn't need to know anything about ports, because it reads it automatically from the TED-TOML. So, and also like authentication. So if you're using client-based authentication on the local broker, that gets very, very messy if you're using Mosquito sub. Whereas TED MQT sub, it just works. So that should be a really nice experience now. And as I said before, we've changed a lot of the regex images. So they're now using the regex instead of regpi, just a brand change there. And it brings a lot of newer functionality. So if you have previous devices which are deployed with regpi images, you can now pull the latest image or build your own image using our repositories. And that should be a seamless upgrade. So we support upgrading from the RugPy world to Rugex, fine. So you can just proceed to do that, but just be aware that the name has changed. And so all of our documentation has been updated to use the new instructions. There's a few tweaks here and there, so be sure just to read up on that.